And you've said something like our traditional way of looking at ADHD as sort of a dopaminergic seeking situation or a neuroadrenaline seeking situation is far too narrow.
Yeah.
What is your interpretation of my brain needs more stimulation, needs to fire more dopamine receptors, and that's part of it?
There's no doubt that the treatments which directly increase available dopamine and noradrenaline across the brain, that they work. There's no doubt about it. In fact, they're so effective.
Yeah.
These medications really, they have, how effective a medication is referred to as its effect size. And the effect size of stimulant medication, for all the criticism they get and all the misinformation out there about them, they're really effective and generally well tolerated medications. And they really do improve things. Interestingly, one of their side effects is a slight increase in blood pressure. And interestingly, they are, in fact, in America more than here, a treatment for POTS. So we could actually be seeing some of the benefits of stimulants through their blood pressure enhancing effects, treating the dysautonomia, which actually is in part the ADHD. So that's a separate thing. But what they also do is they increase dopamine and noradrenaline in the brain. So clearly increasing those neurotransmitters improves things. And until relatively recently, we have reverse engineered this finding to say, okay, well, ADHD must be a problem with the dopamine or noradrenaline receptors or transporters in the brain. And so we've been having all these hypotheses and having all these what we call candidate genes, which are expected genes that are going to be abnormal. Now, in parallel, there's been this sort of study of the genome-wide association studies, where they're basically with bigger and bigger groups of people with whatever disorder you're looking at their genetics and looking for certain genes that stand out as being variants in these groups. And certain genes are coming out, and virtually none of them are to do with neurotransmitter receptors or transporters. They are finding lots of brain-based abnormalities, things to do with neuronal development or synaptic development. So they're finding a few genes around that. And then that's where the story ends from an ADHD perspective. Oh, look, we found these genes and look, they have brain-based functions. Now, what I did a while ago, and again recently actually, is through using AI, I said, okay, I'd like to know the other functions of those genes because genes have various different functions, not just one. And lo and behold, those genes that came up as being important in ADHD that have the scattering of neurological effects also have immune modulating effects. Many of them do. They have connective tissue effects. So there's effects across the whole body. And that's suddenly really interesting. So this is perhaps not just a brain thing, although we have lots of data to show that it is a brain thing, but it's like looking at an elephant and being so honed in on the elephant's trunk that you think, isn't it amazing? This problem, this is, this in animals is amazing. It's got long, it's all this. And then you don't realize that the trunk is attached to the rest of the body. And you have to zoom out and you go, oh, look, there's legs as well. And there's a tail. And isn't it interesting? It's like walking into a shopping centre through one entrance, through the car park and going, oh, this is a pretty grim shopping centre. Okay, it's a bit poorly lit. And then realizing that you could have come in multiple different entrances and seen
Right.
very different things and described in your analysis of the shopping centre just a very narrow perspective of a very big thing. That's how I think it is. So I do think the brain's involved. Of course the brain's involved. But I think the body is involved in many, many cases as well.